Tiffany Arielle here, and we are back with another video in our Learn to Code series. So if you have not seen the previous videos in this series, definitely check the cards above because I will have the playlist there. I would definitely recommend that you check out at least the first two videos in the series. The first one is where I go over all the setup, how to get your Python installed, getting the starter code, getting everything like that. So if you don't have that, you definitely will not be able to follow along. The second one is more so recommended, but not strictly necessary. I did do an overview of Karel, what she can do, what she can't do, and that type of stuff in that video. So I would recommend you at least check out the first part of that video. Additionally, these problems are designed to be done in order just because they do build on each other a little bit, but it's not strictly necessary. So with that being said, let's get into the topic for today. All right, so the problem that we are doing today is RampClimbingKarel. This is in the same link that I gave you guys last time, and it will be in the description box again so that you can follow along as I'm going. And of course, we also have our reference guide, which we have open. The link to this is also in the description box. So it says that we should write a program that has Karel draw a diagonal line across the world with a slope of 1/2 like so. So basically Karel starts here, she goes up, she goes across 2, she puts another beeper, goes up, across 2, etc. Then it says the key to drawing a diagonal line with slope 1/2 is to move 2 steps forward and 1 step up between each beeper. In this problem, you can and should assume that the world is an odd number of columns across. Solving the problem for an even columns as well is much harder and would count as an extension. So in this world, in this actual class, if you do extra beyond what they tell you in the assignment, you can get extra credit. So that's what they're referring to by extension. Then it gives some other assumptions. Karel always begins at the bottom left corner of an empty world facing east. You may assume that the world is an odd number of columns across. They're telling us this again, so it must be very important. Karel's bag has infinite beepers. It does not matter which direction Karel ends up facing. The world is always square. Okay, cool. So let's go ahead and get started, and then at the end, maybe we'll come back and kind of explore why they're telling us to assume certain things, and maybe we can actually do some extensions and, get some extra credit. Okay, so let's go to PyCharm, and we already have our project open, so I'm not going to go over that again. So like before, we are going to copy our template and we're going to paste. It asks us what file name we want, so let's come here, let's copy this, and let's paste, and we click yes, okay. So now we have our file. So we came here and we said, okay, what does Karel need to do? Karel needs to put down a beeper, and then she needs to move to the next space, and then move to the next space, and then the next space. Now, they did not tell us that this world is always 7 columns. They did tell us it's always an odd number, but they didn't say it's always 7. So let's think about how we would know when we are done. So I'll pause for a second and see if you can think of anything. Okay, so the way that we know if Karel is at the end is, notice this is the last beeper, and look, there is a wall in front of her. So because we know that our beepers are always in odd columns, 1, 3, 5, 7, and we know that our world is always an odd column apart, an odd column wide, we know that basically if there's a wall after our last beeper, then we are done. So let's see. How do we know if there's a wall in front of us? Let's go back to our reference and we see, oh, front is clear. Okay, yeah, that seems good. So we know we need some type of loop. So we say while, we say front is clear, meaning, okay, there's no wall in front of us. What did I say? I said we need to put down the beeper and then we need to move to next. So we are like, okay, this is red. We need to write our move to next function. So let's do that. Move to next. So how do we move to the next? We need to move up. Okay, so how do we move up? So we would need to turn left and then move, and then turn right and then move twice. Okay, so let's do that. So we turn left, turn left, then move, then we turn right, and we move again. And now we're like, oh, turn right is in red. But didn't we write this last time? Yes, we did. So we are just going to copy this from here. Now, if we were smart, we would actually have updated like our library functions to include the turn right, so we don't have to keep doing this again and again. But we're not going to do that in the series of this videos, but that would be a good coding practice. In the meantime, we'll just copy and paste. Okay, so we did that. We don't see any red lines. I think we might be good. So let's run this. So I'm going to go to run. I'm going to go to run. I'm going to go to RampClimbingKarel and run program, and nothing happened. Why is that? Let's see. We have our code while front is clear. Ah, that's why. So notice here there's a wall right in front of Karel before we even start. So this while loop, while front is clear, nothing ever got done. So we said, okay, well maybe we need to put the beeper down before we check if the front is clear. So let's stop this. That did not take, okay, stop. And let's try again. So let's run this now, run program. Okay, this seems to work fine. So let's try another world. So we have, what other worlds do we have? We have a 1x1, we have a 3x3, we have a 7x7. Well, let's try the 7x7 because that's what they showed us in the example. And let's run program. Oh, already this does not look right. Yeah, this is not right. So notice here we have two beepers in the first space and we have no beeper in the last space. So there's definitely something wrong here. Now, what is the problem? Now we look at our code, we say put beeper, while front is clear, put beeper. Oh, that's the problem because I'm putting beeper and then in my first space, my front is clear. So I'm putting down another beeper. So what we need to do is we actually need to reverse these order. So we have put beeper, move to next, put beeper, move to next, put beeper, move to next, put beeper, etc. So let's try this again. Let's see if this works now. Oh, nice. This actually works. Okay, let's try another one. Let's see. We have a 3x3 that might work. Let's run. Yep, seems correct. Okay, so I guess we're done with this. That actually didn't take too long. So let's see if we can actually do without some of these assumptions. So it says Karel always begins at the bottom left corner of an empty road facing east. This one, I would say probably the best thing to do would be you would just check for this. I'm not going to go over that in this video, but I would recommend if you guys want to practice more, look at some of these conditions and see how you would basically combine these to determine if Karel is basically in that spot 1-1 and also determine which way Karel is facing. And you can reorient Karel using a combination of moving and turning and things like that. So I definitely that would be a really good exercise. Would definitely recommend that you guys try to do that on your own. If you want, I can do a follow-up video on that, but just let me know down in the comments. You may assume the world is an odd number of columns across. So this is the one that they told us twice. So this must be really important. So let's see what happens if it's an even number. Let's see. We have an 8x8. Let's try that one. We run program. So far it seems fine until it wasn't. Karel has crashed. Check the terminal for more details. Okay, when did Karel crash? Karel ran into a wall is what it looks like. And it looks like Karel moved up. She took one step and then she ran into a wall before she took the second step. Okay, so how can we fix this? Let's go to where Karel is moving. Okay, so Karel turned right, she moved. Okay, so this is what we do. So this is our moving up and this is our moving to the right. So it looks like after she did this is when she crashed. So let's try this, right? Let's say if front is clear, then only if the front is clear, we move. Now, do we need to check before here? I don't know. I would say no. And the reason why we don't need to check before this move is because we know that we already checked if the front was clear right after we put down the beeper. So as soon as we put down this last beeper, we already checked if there was a wall. So I know that I can at least move into this column. What I don't know is whether I can also move into this column. So let's come here. Let's try this again. Oh, that doesn't look quite right. Now we see there's an extra beeper here. Okay, how can we fix that? So where do we put down the beeper? So this is where we put down the beeper. Okay, we tried to move to next. Oh, but the thing is this, we didn't quite move to the next point. We only got partway there and then we stopped. So how can we tell this other function that we didn't quite get all the way? So let's try something, right? Let's try to return a flag. We'll use a Boolean as a flag. We'll just use true and false. So we're going to say if front is clear, move, and then I'll return true. And this true is basically saying, yes, I was able to move to the next. Now, if the front is not clear, I'm going to return false. Now, this can be written in a couple different ways. In this case, I just have it like this. I could also do this, but this is really the same thing. And the reason why in this case this is the same thing is because this is a return. Return is going to get me out of the function that I am in. So if I hit this line and I return true, then I will never get to any other lines. So I'm going to change this back to how it was because I just like this way better. Okay, so we have this. So now we're like, okay, well, we're returning a variable. So what do we do with this number? Let's do this. So we're going to make a new variable. We'll just call it put. And we'll say put equals move to next. And then what we'll do is we'll say if put, then put beeper. So only if this thing returned true, saying that it got all the way to the space where it was going, then I'll put down the beeper. Otherwise, I'm not going to do anything. And if I did not return true, that means that the front was blocked. So when we get back up here, my while front is clear is going to tell me that basically there's a wall in front of me. I'm going to exit. I'm not going to do anything. So let's run this now again. Run program. Nice, success. Okay, let's try another one. Oh, we have a big one. Let's try 40 by 40 because why not? And let's run this. Ooh, this one's fast. Ooh. Success. Okay, seems like we did it. Okay, let's go back. What other assumptions can we address? Karel's back has infinite beepers. Okay, this, I feel like you would probably have to check, like, oh, if you run out of beepers, but you could do a similar type of thing where basically anytime you go to put down a beeper, you would just check if you have beepers in your bag, which in our reference, we do have an option for that. So we would write if beepers in bag, etc. Not going to really do that. Does not matter which direction Karel ends up facing. This is similar to the last time. If Karel was supposed to face east, we could easily just turn Karel around until she was facing east. The world is always square. Now this one seems a little bit interesting. Why does the world have to be square? Let's try something. Let's see. There's this 8 by 1. Let's see what that's about. 8 by 1. Let's run. Run program. Ooh, that's bad. Okay, so now Karel crashed when she was trying to go up. But okay, we already solved a similar problem. We can probably solve this one too. So before Karel crashed when she was trying to move to the right, now she's crashing when she's trying to move up. So let's see about this. We can do the same thing, right? If front is clear. Oops, it deleted my stuff. So let's type this again. Move. Now, let's think about this. If my front was not clear, do I need to still move to the right? No, I don't. That's not what I need to do. So what I'm going to do is I'm just going to move all of this inside the if function as well. So only if, after I turned left, only if there's no wall right above me am I going to try to move up. And only if I do that am I going to try to move right and continue along with what I did before. Now, same type of situation. We say, okay, if the front is clear, and, I moved to the right, that means success, I return true. If I moved up, but not to the right, I return false. But now we say, oh, but what if I couldn't move up? I need to return false again. So we're just going to add this, return false, and let's see if that solves our problem. Run program, and cool, it did. So that's good to know. So it looks like we've addressed most of the key assumptions. This is really the only one left, which I already talked about. So with that being said, I think we are done for today. So if you did enjoy this video, please don't forget to like, subscribe, and share with all your friends. And don't forget to come back for the future videos in this series. And I'll see you next time. Bye.